This is a presentation from Diversified Technologies, Inc. on their current SBIR effort to provide a solution for the launch, recovery, and handling of Group 3 to 5 unmanned aerial vehicles, or UAVs, aboard Navy Expeditionary Sea Bases, also known as ESBs. This work is being done for and in coordination with the Naval Surface Warfare Center. First, a little background on the company Diversified Technologies, Inc., or DTI. DTI is a small business founded in 1987 by Dr. Marcel Gaudreau. Located in Bedford, Massachusetts, DTI has 125 employees with backgrounds in electrical, mechanical, aero, physics, and materials engineering. Their core technologies are solid-state modulators, power supplies, and high voltage, high power switching. DTI's primary industries are radar and defense, along with power conversion and high energy physics. On the right, you can see some examples of their products, such as X-band transmitters or submarine power converters. Under this effort, the Navy has awarded DTI a Phase 2 SBIR to develop a rapid launch and recovery system to transition Group 3 to 5 UAVs from aircraft carriers to ESBs. Shown on the right here is the Expeditionary Sea Base, USS Lewis B. Puller. ESBs provide the Navy more capability and flexibility needs. The key specifications are decelerating a 6,000-pound UAV with a 30-foot wingspan from 160 knots to a full stop in under 300 feet. Additionally, repeating this once per 2 minutes and then launch in that same 300-foot footprint. Current Group 3 to 5 UAVs are launched with a rocket assist and recovered with a parachute. The problem with this method is that it does not support swarms of UAVs, and parachute recovery at sea is resource intensive. DTI's solution is a stowable, automatable sponson system that will accelerate or decelerate a carriage carrying the UAV. This eliminates the need for the rocket assist and parachute and minimize the onboard footprint, enabling the support swarms with reduced manning requirements. Taking a closer look at the stowable sponson system, there are 2 support steel outer cables and 1 center drive cable, which is accelerated by an electric motor. The carriage slides along the support cables, pulled by the drive cable to either launch or intercept the UAV. There is closed loop controls and a guidance system to match UAV carriage speed and position during recovery. The table here shows the anticipated system performance throughout the program. The size and weight of the UAV have been scaled up under each phase of this effort in anticipation of meeting the full system specification for the Phase 3 demo. DTI completed the Phase 1 and Phase 2 base efforts, successfully demonstrating scaled performance of key technical aspects, and is now in Phase 2, Option 1, launch demonstration. DTI is now demonstrating a scaled system for mid-sized Group 3 UAV at the lower end of the specification and, having adapted the design appropriately, is using a land-based prototype for this demo. You can see some images of the motor and the sponson adapted, and key component testing is underway or finished, and the entire system is ready for integration testing. Here is a detailed look at the program schedule with the red line indicating DTI's current status. DTI is presently completing Option 1, Task 5, Scaled Launcher System Fabrication and Test. Once launch testing is complete, modifications may be identified and completed in anticipation of recovery testing, which is Option 2, Task 7. The goal of this program is to increase UAV usage because UAVs offer very effective solutions to tasks such as surveying, monitoring, surveillance, and combat. So, this design enables increased usage by eliminating flight deck space and minimizing mission deck space needed, allowing UAVs to be deployed on smaller vessels. In addition, UAVs can be deployed and retrieved much quicker for swarm capability with a rapid automated system. The system requires little operator involvement and is also easily retrofitted to existing ships or land-based operation. In order to transition this program to the fleet, a full-scale launch and recovery system must be demonstrated. Following the current Phase 2 testing, optional work with Kratos UAS or other UAV manufacturers is anticipated in order to develop a system geared towards the target user. That will complete the Phase 2 work, and DTI will start working on the transition plan for the Phase 3. Their plan is to integrate with a prime contractor in this industry to incorporate the power system and the sponson system into the ESB design. Additional funding will be required to make that full Phase 3 transition. DTI has completed over 59 Phase 2 SBIRs and 22 Phase 3 SBIRs, making us one of the DoD's most successful SBIR commercialization companies. They've generated over $250 million of SBIR-derived products into government and commercial markets. DTI has plans to work with platform prime contractors for this effort and will likely split this effort between DTI and those primes. Additional platforms and programs we are looking at are Marine Corps, Surf Devron 1, NavAir, N98, and PMA 268. Finally, you can pause here for contact information. Thank you for listening, and please feel free to reach out to any of DTI's points of contact shown here.